In this video, we're going to continue talking about exponent rules, but we're going to talk about properties that involve 0 or 1, and then properties involving negative exponents. So just those two rules for this video. So I've included a copy of the notes that you guys already took on the first set of rules. So let's just continue from those notes on this page. So the properties involving 0 or 1. So when anything is to the 0 power, it just equals 1. Is the rule for that one. And anything to the first power is really just equal to itself. You can just write it without the 1. So that's really the property that deals with 1. So let's write a few more examples over here in the next box. So if I have 17 to the 0 power, for example, that would just equal 1. If I have 1,534 to the 0 power, that would still just equal 1. If I have 3xy to the 0 power, only the y has the 0 power for this one, so I would just say that's equal to 3x. Like the y would just go away because that's just equal to 1. So it's like 3x times 1, which is just equal to 3x. And if I have 3mn to the 0 power, in that case, everything is to the 0 power, so it would just all cancel out and equal 1. All right, let's look at some properties involving negative exponents. So for negative exponents, you want to move them to the numerator or the denominator based on where they're originally located, because that is what fixes the negative. So in this example, I have ax to the negative n power. So a is not affected by the negative n, but x would need to move to the denominator to make it become a positive n. So let's look at another example. So if I have 2x to the negative third power, for example, I don't need to move the 2. I only need to move the x to the denominator to make it become a positive. So let's look at a few more examples. Like if I have negative 5x to the negative third power times y, I just need to move the x to the denominator because everything else is not affected by the power of negative 3. Only the x has that exponent, so it's the only part of that expression that needs to move to the denominator. Another example would be if you have 3x over y to the negative 2 power. So let's say you started with a negative in the denominator, then you need to move it to the numerator. So that would become y squared over 3x. Now I was just drawing some lines to break up our examples so they don't get all crowded. But that would be it for now. So let's look at a few more down below. So a few more examples involving 0 or 1. So number 1 says 89 to the 0 power. So that would just equal 1. Number 2 says 5xy to the 0 power. So y just equals 1, and you're just left with whatever else is there, which is 5x for this example. Then number 3 has p squared times r to the 0 power over p to the 0 power times r cubed. So when you have other things in the expression, you want to leave them, but the 0 powered terms would just go away. So you have p cubed over r cubed, which we can't do anything with that because we have different bases. They don't match. And for the last example for this rule is 1 over 2b to the 0 power. So since everything is to the 0 power, this would all just equal 1. All right, let's look at a few more of the negative exponents. So the negative exponent rule, remember, is to move it up or down depending on where it's located. So for this example, I have 5 that would stay in my numerator, but I would need to move the b and make it a positive 2 exponent, and the c and make it a positive 3 exponent to the denominator. So they had to move to the bottom. Number 2 has 1 over t to the negative 6. So it looks like this. And in order to fix it, I have to move that to the numerator. And since there's only a 1 in the numerator, I just would have t to the 6th. So technically it's over 1 now, but we normally just write that as t to the 6th. All right, in the next example, we have 3x divided by x to the negative 6th power. So what I like to do is just fix that negative first and then think of what else I might need to do with this expression. So it'll be 3x times x to the positive 6th power, and it's all over 1. And then I can use my product rule to combine these since they have like bases. So I have an understood 1 on that first x, and I want to add those exponents together. So it'll be 1 plus 7. So I still have my 3, and then I have x, and now it's just to the 8th. Or excuse me, I wrote a 7. Excuse me. That's supposed to be a 6. I think I was thinking ahead. So the final exponent would be a 7. Okay, one last example. We have 3b over negative 5 and then c to the negative 1 power. A really important thing to note is the only thing affected by this negative exponent is the c. So it's the only thing that needs to move in this expression. So I'm just going to move that up to the numerator. Now it has a positive 1 exponent, which we don't have to write. It's understood. And then the negative 5 is still in the denominator. So then all we can really do with this one is just put the negative right out front. And that would be all we could do. Okay, so that is good for the next two properties of exponents.